Okay, this video is going to be a brief summary of how to do function evaluation, also noted as notation because sometimes it's called function notation. Okay, so if you're doing this in your notes, go ahead and pause this right now so you can copy all this information right here first. So basically, we're going to use f of x instead of y to evaluate the function graph at specific x values. What that means is that we have a function, usually with a graph attached to it, and we're trying to find the y value that goes with a specific x value. So x equals something, okay? And we want to see, well, what is the y value that goes with it? Because usually they come in pairs, right? X, y as an ordered pair. So to do this algebraically, which is the, I guess, slightly more difficult way, here are the steps. Okay, the first thing we do is we replace the x's with a parentheses. So put a parentheses wherever you see an x. Okay. Second step is to substitute or plug in the number, and I should underline that, the number or expression, because sometimes it could be an expression, in all the parentheses. So where x used to be, we're going to replace it with whatever we're trying to find. Okay. And finally, we're going to use PEMDAS, which is the order of operations, to simplify the expression. And I did go ahead and put the right side here because a lot of people get confused. They don't know what to do with that f of some number. So we're looking at the right side of the equation, okay? So we're going to go right into an example so you can see what I'm talking about. And I'm going to try to show you a couple algebraically as well as graphically. Okay, so let's say we have the function f of x is equal to 3x plus 1. Something simple. Okay, and I want to evaluate f of negative 2. Okay, so the first thing I need to do is rewrite this function, because it's my function, with parentheses wherever I see the x. So this already has a parenthesis. I'm just going to leave it like that. So I'm going to do f of parentheses equals 3 parentheses plus 1. Okay, after this, we take our value, which is this number right here, and we plug it into wherever I had an x. So negative 2 goes here, and it goes over here. Okay, now the PEMDAS portion, this is where we look at the right side only. This piece right here, this is just saying that the function at negative 2 equals to whatever this is equal to. Okay, so we can leave this part the same. I'm just going to leave it like that. So this is equal to, I'm going to evaluate this. So I first multiply here. 3 times negative 2 is negative 6 plus 1. And I'm going step by step. I'm sure a lot of you know the answer already. And negative 6 plus 1 is negative 5. So that means that f of negative 2 equals negative 5. Okay, now what this also means is that on the graph of this function, I have the ordered pair negative 2 comma negative 5. So this ordered pair is part of this function here. Okay, I'm going to go ahead and do one more algebraic and then do some graphical examples. So let's say we have something a little bit harder, just to complicate it just a little bit. Let's say I have g of x, just to change it, is equal to, we'll say 3x squared minus 2x plus 1, okay? And I'm going to have you find, and I'm going to change the wording just because it can be different. Find g of negative 5, okay? So just like before, I'm going to rewrite this with parentheses. Let me change colors real quick. So I'm going to say that g parentheses is equal to 3 parentheses squared, don't forget that square, minus 2 parentheses plus 1. And again, the reason I'm doing this is because we want to see what the y value is, what f of x, g of x in this case, is equal to when there's a negative 5 in the x position. Okay, so I'm going to go ahead and plug in that negative 5. Okay, so g of negative 5 is equal to, and then let me plug it in here. Okay, and this is half the battle. And now we're going to evaluate all this. So this is where some of you might get a little bit lost because we forget the order of operations. The first thing I need to take care of is this right here, this square, because we always do parentheses and then exponents, okay? So -5 squared is 25, so I have 3 times 25, okay? It's positive because a negative times a negative is always going to be a positive, okay? Minus 2 parentheses -5 plus 1. Yes, I'm going very slow. And then from this point, I can distribute. So I know that 3 times 25 is 75. I know that this right here, 2 times -5, is going to be -10. But because there's a minus here, it's kind of like saying a minus times a minus. So that's going to be a positive. So plus 10 and then plus 1. I'm going to bring this down just because I'm going to put the answer now. So altogether, 75 plus 10 is 85, plus 1 is 86, which implies that my ordered pair is -5, 86. So when I graph this, if I wanted to find the y value for this at -5, it would be 86. Okay. I'm going to go ahead and do one more example with a graph. I'll leave it the same color, it's fine. So let's say we have, and this is graphically, okay? Graphically is actually a lot easier because there's no calculations involved. So let's say we have a quadratic, okay? Something like this. Let's say I have points, this here, it says 0, 1, 2, 3, 4. That's about the point that I want, okay? So let's say we're looking for, it says evaluate f of 2, and this graph we're going to say is f of x, okay? Well, what this means, I'm going to put a different color here. This means that we want to know what is y. Okay, remember y is the same as f of x when x equals 2. So that's what this means specifically. So I'm going to go ahead and do that. I'm going to go to my x value. So my x's are here, my y's are here, and say, well, this is 2 right here. So if I go up to the graph, okay, it meets about right here. And of course, this is a sketch, so you know, it'll be better on paper. And it goes right across to 4. So 1, 2, 3, 4. So because of that, my answer for this is simply going to be 4. So I can say that f of 2 is equal to 4. And that's it. As simple as that. Okay.